Hi everyone, this is Infinity YouTube channel. Please remember to like, subscribe, and share. Alright, last time we introduced Anova, that is analysis of variance. So today we are going to solve an example on the analysis of variance. We are going to see how we can analyze variance of samples. Alright, so with me here is a question from the Federal University of Petroleum Resources, Delta State in Nigeria. So the question says that the table below gives the number of classes missed during the first semester by 25 students, randomly selected from petroleum, marine, and chemical departments. So these are the values of the students that missed the classes. So from there, we're asked to state the null and the alternative hypothesis. We're asked to show the rejection and the non-rejection region with a significant level of 0.01. We're asked to calculate the SSB, SSW, and SST. We have to establish the variance between samples and variance within samples. We're asked to find the calculated value of F, and the last is that we should construct an Anova table for this problem. All right, so the first thing we have to establish here is that we have to establish that T1, T2, and T3 should represent each of the departments. So if T1, T2, and T3 represents each of the departments, so we can say that let T1 represent petroleum, let T2 represent marine, and let T3 represent chemical. Right? So then for us to establish the null and the alternative hypothesis, we need to calculate the mean of the T1, T2, and T3. So to calculate the mean, let's call that bar x of T1, the mean of the first one, will be equal to the addition of all the components in the petroleum department. So if we should add all the components, we are going to arrive at 172 as all the components, divided by the total numbers that these components fall on. And these total numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That means all the values are 10 in number. So 172 divided by 10, which will give us 17.2. So let's do that for x of T2. By x of T2 will be, if you should calculate all of the marine departments, we are going to arrive at 99. So okay, so 99, and if you should check how many marine students that falls in each of this group, they are 9 in number. So you have 99 divided by 9, which will give us 49.5. All right. So 99 divided by 9 is 11 rather. 99 divided by 9 is 11. So all right. So if we should divide that, 99 divided by 9, we are going to have 11. So the next is bar x of T3. So by x of T3 is actually the total numbers of chemical. If you add all the components on the chemical column, you are going to have, on chemical row, you are going to have 51. So at the total number of students that falls on this category, there are 6 categories. So divided by 6. So which will give us 51 divided by 6 should be 8.5. All right, 51 divided by 6 is 8.5. All right, so since we have calculated for the mean of all these values, so we can proceed to state the null hypothesis. Now to state your null hypothesis, the null hypothesis is represented as H naught. So to state that null hypothesis, we are going to assume that all the means are equal for the null hypothesis. So we can say u1 equals u2 equals u3 as the null hypothesis. Now the next we are going to do is to state our alternative hypothesis. Our alternative hypothesis. So our alternative hypothesis is giving us H1. So the alternative hypothesis is simply you are going to look at all the means that you've calculated so far. Are they equal or aren't they equal? So as you can see, they are not equal. Hence, U1 is not equal to U2, which is not equal to U3. So we have established our null hypothesis and our alternate hypothesis. Hence, from what we've seen so far, we can see that we can say that the population means are not equal. The population means are not equal. So the next we are going to do is to focus on the next question, which is we're asked to show the rejection and the acceptance region, the rejection and the non-rejection region. So to do that, we are going to solve this and at the long run, we are going to complete the solving of the second part, that's of this B part. So let's solve for the first part of this B part. So what do I mean? So to solve for the B part now, so what we do is to establish our K. So what's our K? K is the degree of freedom, and K is equal to how many, K represents how many departments we have. So how many departments do we have here? As you can see, there are 3 in number. Hence, K is equals to 3. So the next is N. N, as stated in the first video, is the total numbers of all the categories, the total number. So as you can see, N is gotten from here, 10 plus 9 plus 6. And 10 plus 9 plus 6, that is N is equal to N1 plus N2 plus N3. Which is equals to 10 plus 9 plus 6, which is equals to 25. So now to establish our degree of freedom of the numerator, we can say K minus 1, which is the degree of freedom of the numerator, is equals to 3 minus 1. And 3 minus 1 is equals to 2. And the degree of freedom of the denominator is N minus K, which is equals to 25 minus 3. K is 3, which gives us 22. So since we have that, so the next we are going to do is to establish our F tabulated. Okay, we are going to establish what we call the F tabulated. So it is that F tabulated that will help us to know if we are going to accept or reject these samples. Okay, so that F tabulated is calculated thus. F tabulated, let's call that F tab, is equal to, you go to your F distribution table. This is my F distribution table. So under my F distribution table, I have some values on my vertical and some values on my horizontal. So this vertical region is the degree of freedom of the denominator, and the degree of freedom of our denominator is 22. So we go to this side of the of this table, we trace 22. So as you can see here is my 22. So if you look at that 22, you're also going to find alpha there on the same line. So just look for the alpha, since the equation gave us alpha as 0.01. So go to the same line, you on that 22, check alpha 0.01. See my alpha of 0.01 here. Now look at the top side. That is the degree of freedom of your numerator. So the degree of freedom of our numerator is 2. So trace 2, which is here, trace it down to 0.01, and from my value here I have 5.72 as my value. So my F tabulated is 5.72. Now before we continue to solve, remember I told you that we are going to do this B in 2 parts, right? So we have established the first part, then at the long run we establish the second part and complete the B. So let's continue. Now let's solve for the C part of the question, which says calculate the SSB, SSW, and SST. So our SSB now, to calculate for that, we know that SSB is equals to T1 squared over N1 plus T2 squared over N2 plus T3 squared over N3 minus summation of x all squared divided by n. So this is the value of our SSB. So we can continue by saying T1, which is 172 all squared divided by 10. That is all these values that we have, right? All these values, just square the t's. Okay, so plus 99 all squared divided by 9 plus 51 all squared divided by 6, then minus, so this summation of x is simply T1 plus T2 plus T3, which will give us 172 plus 99 plus 51. Now when you add them, you square it, okay, right? So if you square it, so summation of x squared is going to give us 103684. Now if you add all these and square it, you're going to have this value. So we can say 103684 divided by n. This n here is the total number of all the n, that is our n1 plus n2 plus n3. So if you should add all our n's together, you are going to have 25. So this is all we have. Now if you should subtract this, what you are going to arrive at is 333.54 as the value of our SSB. Now this is on the C part of the equation we are solving now. So now our SSW is actually equals to the summation of x squared into T1 squared over N1 plus T2 squared over N2 plus T3 squared over N3. Now this summation of x is simply the square of each of the t's. Are you there? The square of each of the t's. That is the square of 21 squared plus 14 squared plus 29 squared plus 14 squared plus 22 squared plus 7 squared plus 19 plus 15 plus 19 plus 15 all squared. If you square all of them, now let me, from my calculator here, I have T1. If I should square all my T1, I'm going to arrive at 3298. 3298. For my T2, if I should square all my marine departments, I'm going to arrive at 1121. And if I should do that for the chemical, I'm going to have T3 as 477. Hence, my SSW is equal to the summation of each of them, right? If I should sum each of them, I'm going to have 4896 minus T1 squared, T2 squared, T3 squared, till so we have 172 all squared divided by 10 plus 99 all squared divided by 9 plus 51 all squared divided by 6, right? So if you should subtract that, we are going to have 415.1. So this is the value of our SSW. So we can go further to calculate for our SST according to the equation. So the question asks us to calculate for our SST. Hence, SST is we know that SSB is equals to SST minus SSW. Hence, we can say that our SST now is equals to SSB plus SSW. So if that is the case, so we have 333.54 plus 415.1. So if I should do the maths, I have 333.54 plus 415.1. So from my calculator here, I have 748.64. So this is the value of our SST. Now let's continue. So for us to calculate for the next is D, establish the variance between samples and the variance within samples. So that is our D part. So the variance between samples is MSB, and MSB is equals to SSB divided by K minus 1. And our SSB from what we have is 333.54, and our K minus 1, of course, is 2. So if we should divide that, so 333.54 divided by 2, we are going to arrive at 166.77. Now our variance within samples, which is our MSW, is actually equals to SSW divided by N minus K, which is equals to 415.1 divided by N minus K, which is 22. So 415.1 divided by 22 gives us 18.868. So I can approximate probably to 2 decimal place, since I'm working with 2 decimal place, to 18.87. Now that is my SSB. Now let's we are done with the D part. Now for the E part, now they ask us to calculate for the F calculated. Recall that we've done for our F tabulated. So now for our F calculated, let's call that F cal, will be equals to our MSB divided by our MSW. So our MSB from here is, actually 166.77, and our MSW is 18.877. Now if you divide 166.77 divided by 18.87, we are going to arrive at 8.84 approximately. 8.84 approximately. Now the next we are going to do is they ask us to construct an Anova, that we should construct an Anova on for this problem. So we are going to construct an Anova for this problem. So to construct that Anova, what we do, we are going to create a table. So to construct that Anova, we are going to create a table. So on that table, I'm now on my F. So on that table, what we do is we create a table that is source of variation for table 1, degree of freedom as the second one, sum of squares as the third one, mean value as the fourth one, and then value of statistics. So value of statistics as the last one, right? So on this source of variation, of course, we have between and we have within. So between and within. So you close that. So the next we are going to do on this within, our degree of freedom for the within is 2, right? Our degree of freedom for the for the between is 2. Then for the within, we have 22. Okay. Then for our sum of squares for the between, our sum of squares for the within, that is our SSB. Our SSB, we got it as our sum of squares. We had it as 333.54, and that of the within, we had it as 415.1. 415.1. Now on our mean value, the mean, which is the MSW and the MSB, on the MSB we had it as 166.77, and on our within we had it as 18.87. Now for our value of statistics, which is actually the F calculated, so you can say F is equals to basically what we've done here. So that is 166.77 into 18.87. So you can come down here and write total, of course, is 8.84 as our total. So this is the value and this is the answer for our F part of the equation. So now to establish the second part now, the B part, which I stated earlier on, if our F calculated is less than our F, if the F calculated is lesser than our F tabulated, we reject. Now if our F calculated is greater, this time if it is greater, we accept. Okay, so we are going to accept. So from the question this question that we solved, are we going to accept or are we going to reject? So just answer the question by yourself. Now from the question that we have here, we were asked to of course draw the curve. Okay, you are going to draw a curve to show the rejection and the non-rejection region. So to draw the curve is very easy, very simple. So what we just do is just draw a line and then take a curve, right? So take a curve. Now on that curve, you are going to create a region here. So create that region as a region where you know if you are accepting or rejecting. So this line and the horizontal is our F distribution. So this point here is the point of our F tabulated, right? So our F tabulated was 5.72. That was our F tabulated. So this is the curve of the region. So that is how to draw it. Now you can further say that this test that we did, that in a right tail test, we accept the hypothesis. Okay, in the right tail test we accept the hypothesis. So in Anova we make use of the right tail test. It makes use of a right tailed curve. So this is basically all you need to know about the Anova and how to calculate for the Anova. So I hope this video was helpful and interesting and understandable. Please remember to like, subscribe and share. Thank you.